Hello chemists, today we're going to be talking about our second type of spectrographic data analysis, and that is infrared spectroscopy. This is different from mass spectroscopy because it is looking at the presence or absence of bonds, as opposed to mass spectroscopy, which was looking for the mass of certain fragments of a molecule and the mass of the whole thing. The way that mass spectroscopy works is you shine an infrared light through a sample that has been turned into a gas, so you heat it up and you shine a light through it. And if there is a bond present, that bond will absorb a certain frequency of light. And it will absorb that certain frequency of light by bending or by stretching. And those different bends or stretches are indicative of the presence of certain types of bonds. What do I mean by that? Well, I mean that there is, we can see on this graph, this peak right here. Looks like that peak, we call it a peak even though it's pointing down, just for clarity of language along with the mass spectroscopy. So these are peaks even though they are pointing downwards. This peak here looks like it's between around 3,000 and somewhere in the upper 2,000, so like 2,800 or so. If I look at our graph to the, if we look at our the resource sheet you've been given and look for those numbers in the range, you can see that alkane bonds, that is C to H bonds, should have a medium to strong peak with a couple of subpeaks in the 2850 to 3000 range. So this tells us that there are C to H bonds present in our sample. Then we keep moving to the right. We see this peak right here. This peak looks like it's around between 1700 or so, right around 1700, and it's pretty narrow. So if we keep looking down, we can see that aldehydes and ketones have peaks in the 1710 to 1740 range for aldehydes and ketones both. Can't really tell which one of those two it is, but we know that there's going to be some sort of C double bond O present. And then we stop looking, because when we get to 1500 on the wave number x-axis, we stop looking. Anything to the right of 1500 is what's called the fingerprint region, and basically it's too complicated for us to get any useful data from it, so we just ignore it. There will be some things on your resource sheet that refer to peaks in the fingerprint region. Just don't use those as indicators of what your compound is. We're looking at only things 1500 and up. A big difference between mass spectroscopy and infrared spectroscopy is that in mass spectroscopy, if you don't see a peak, that doesn't really tell you anything. In infrared spectroscopy, if you don't see a peak, that does tell you something. So if there was a alkene bond, a C double bond to H, so an H bonded to a C, which is double bonded to something else, probably another C. If there was one of these bonds present, we would expect to see a peak right around here-ish, just a little bit above 3,000, 3020 to 3,100 it says on your resource sheet. We do not see a peak there, so we know that there is definitely not this bond present. Absence of a peak for infrared spectroscopy does give you information. So from this graph, we can tell we've got some sort of compound that has C to H bonds and C to O bonds. From that information, we can tell that it's going to be some sort of aldehyde or ketone, and not really anything else. We can't tell how big it is, like how heavy, and we can't tell whether it's one long molecule or whether it's got a bunch of side chains, but we can tell that it's going to be some kind of aldehyde or ketone because it's got only C to H and C double bond O present. So the way we approach these infrared spectroscopy graphs is we look for peaks, kind of identify and describe the peaks. So I would call this a strong, broad peak between 3,000 and 2,850, and that peak is going to be indicative of the presence of C to H bonds. Then I move over here. Any other peaks that are present, I also describe those. You'll need to refer to them by their shape and size and intensity. That means a broad or narrow peak is the shape. The size is basically how broad it is as well. And intensity is how far down the graph it goes, like how close to the bottom of the graph it gets. That's it.